All right, so we're moving into geometry today. And in geometry, what you're going to see is a lot of postulates, definitions, and theorems. And then you'll see a lot of proofs and diagrams. And what's really hard about geometry is that it really is like a new language. You're going to learn basically a new language when you learn geometry. And things sound weird, and you'll see words and terms and symbols that you don't normally see in English, and that you haven't really seen much of in algebra. Postulates and definitions, these are sort of similar. These are things that we know about geometric shapes. So today we're going to learn the segment addition postulate. This is something that we know about line segments. Okay. Theorems are things that we think we know. But a theorem in geometry requires a proof that actually shows that it's true. So how do we prove a theorem? We appeal to postulates and definitions. So we'll learn eventually something called a two-column proof, which is where we show the logical proof going from one part of a theorem to another part of a theorem. Or taking some sort of a diagram and showing that something is true about that diagram. And a lot of geometry is going to feel kind of contrived. Basically, we're like drawing these diagrams and then proving weird things about them. Like we can prove how big an angle is, or we can prove that two triangles are congruent. And you may wonder, well, why would we want to do that? And a lot of geometry doesn't talk about the why, right? We're mostly going to focus on the how. How do we show that this triangle is congruent to this? How do we know that this point is on this line segment, etc.? Okay? But we will have many discussions too about why or where you might apply that. And I encourage you to imagine for yourselves too, how would this be useful? Right? Where might someone want to use this? Why do we need to learn this? All right. So we're going to start with a postulate, the segment addition postulate. I'm going to start by showing you this with a diagram. If I have a line segment, AC, and I have a point that's on that line segment, we'll call that B, then I know that the point is on the line segment if and only if this plus this equals the whole thing. So that sounds like a totally wacko way of saying something that's probably completely obvious to you, right? But I want to show you how we could write that in geometry. So this plus this equals this. So we would say line segment AB plus segment BC equals segment AC. And if you pay close attention to the way that I said that, the way this postulate is usually stated is that point B is collinear with A and C. Or sometimes you'll see this said a different way. Point B is on line segment AC. And then this is one of those weird words, IFF. I'm not spelling if wrong, but in math this means if and only if and only if AB plus BC equals AC. And I think the meaning of this becomes clearer if I draw another diagram, like if I draw this. Here's AC, and here's point B. Right? Point B is way up here. This is a counterexample. So this is like disproving this postulate. It's not disproving it, but it's a counterexample to this postulate. If B is not on the line, then AB plus BC will not equal AC. Right? This plus this is not going to equal this. So, the segment addition postulate says, if point B is on line segment AC, if and only if AB plus BC equals AC. And that's it. That's your first geometry postulate.
That's it. That was easy.
That's it.
So pretty much any surface is pretty much